The question we now want to answer is, what do we mean by the slope of a nonlinear function? Okay, so, in your previous classes in algebra and stuff, you've learned that if you have a line, just a straight line, you can find the slope, right? You take 2 points. We'll call this one x1, y1, this one x2, y2, and the slope is y2 minus y1 over x2 minus x1. And it tells you kind of how steep it is, right? The larger the number, kind of the steeper the graph is. And if it's positive, you know your line is increasing. And if it's negative, you know your line is decreasing. Okay? But what if we had something that wasn't a straight line? What if we have something like this? What would we mean by the slope of that? Well, so far we don't have anything that we can use to talk about that. And what we actually do is we're going to be able to find a function that talks about the slope, but we're going to have a different slope at every point. So for a line, we have a slope of that whole line. But for a function, a nonlinear function, we're going to have to talk about the slope at any point. So let's say we pick this point right here, and we want to find the slope. Well, the slope means kind of how steep it is, right? How fast is it changing? Remember, slope of a line was also the average rate of change. So what we actually want to find is what's called the slope of the tangent line. And the line that's tangent to this function at that point is going to be the line, the straight line, that only touches the graph at that point, at least close by there. And we're going to find the slope of that point. And we'll call that line. We'll call the slope of that line the slope of the curve at that point. Okay, so here maybe that's something like 1, right? What about where we kind of level off here? If we drew a tangent line there, we would be horizontal. So right there, maybe it has a slope of 0. And over here, if we pick a different point, right, that tangent line now has a negative slope. So at this point, we would have, maybe it's something like -1/2. And so we'll have a new function, and we'll actually call it the derivative, that will give us the slope at any point. Now, how do we actually go about finding the slope of the tangent line? And that's a very good question, and it's actually why we learned about limits. So let's say we want to find an equation of the tangent line. We want to find the slope, and then we'll actually write it out. And we want to find the equation of the tangent line of f of x equals x squared at x equals 2. So let's draw what that means. So here's our coordinate axes. And if we look at the graph x squared, and we want it where x equals 2. Now, at 2 there, our y value, 2 squared, would be 4. So we're looking for the line that just touches at that point. We're looking for the equation of that line, and the slope will be the slope of our curve at that point, or our derivative. Now to find it, what we're going to do is we're first going to pick another point on the graph. So for example, let's pick the point 3, and if we square 3, we get 9. Okay, now we could draw this line between our 2 points here, and it's not a tangent line, but this green line is called a secant line, a line that goes between 2 points. And we could find the slope of our secant. So for our green secant here, our slope, we would do 9 minus 4 over 3 minus 2. Our slope would be 5 over 1, or 5. Now, we can see that 5, this line is much steeper than the line of our tangent that we're trying to find. So we know that's not right, but at least it gives us a starting point. Well, what if we pick a point closer to 2 than 3 is? So, for example, what if we picked 2.5? And if we square 2.5, we get 6.25. Okay, so then we could draw that tangent line, or secant line. And let me get rid of, oops. So that was our first secant line. Now I'm going to draw this one. Okay, and we see it's still not our tangent line, but it is closer, right? Our first tangent line, or secant line that we drew was this one, and at least our green one now is closer to our tangent line. So let's find our slope. And I'm gonna, put a 3 here. That was when we used our x value of 3. When we now use 2.5, we would have 6.25 minus 4 over 2.5 minus 2, which would give us 2.25 over 0.5, which gives us 4.5. Now, what if we keep doing this? What if we did something closer and we chose something like 2.1? Well, that would give us a secant line that's even closer to our tangent. And then we could take something smaller and smaller. And we can actually use our calculator here to help. So let's see if we can come up with a function that represents this slope. Well, we're always using 2 and 4, right? So we're always having, so if we call this x, we're always doing x squared minus 4 over x minus 2. And we want values that get closer and closer to 2. So let's go to our y equals and let's put in x squared minus 4 over x minus 2. Okay, and like I said, we're taking values that get closer and closer to 2. So let's make a little table. I'm going to turn my table set to ask so I can put in. So when we put in 3, we saw that we got 5. When we put in 2.5, we saw that we got 4.5. Well, what if we put in something like 2.1? Well, then we get 4.1. And what if we put in something even closer to 2, like 2.01? Well, then we get 4.01. What if we picked a number? We didn't have to pick a number bigger than 2. We could have picked something less than 2. What if we picked something like 1? Well, then we would have gotten 3. And what if we picked something less than 2 but bigger than 1? If we picked something like 1.5, then we get 3.5. If we do 1.9, we get 3.9. So from both sides, this slope, the limit of our slopes as x goes to 2, as we get closer to that value we're looking for, is 4. So we would say the slope of the tangent line is 4. Actually write that out as slope. Okay, so we're using a limit, right? We're using the limit of these secant lines to find the slope of the tangent line. Now, we were asked to find the equation of the tangent line. We want to find the equation of this black line. Now, hopefully you remember from pre-calculus or algebra that we can use the point slope form, y minus y1 equals mx minus x1. Well, we have our slope, our 4, and our point is going to be this point right here that's on the tangent line, 2, 4. So when we plug that in, we've got y minus 4 equals 4 times x minus 2. And if we want to put this in slope-intercept form, we would distribute the 4, and then we can add the 4. And we see that this black line right here, let me highlight it, this tangent line that we found has the equation y equals 4x minus 4. Okay, so here this is just kind of feeling out, kind of showing you how the graph we want to find, we're finding the limit of secant lines, and we'll actually have a formula that will allow us to do this.